Now we have this question that y equal to 4 minus x squared. Find the point on the function. Elise, you okay?
Yeah.
You look like you're dying. Don't die on me, please. You okay? Do you need a soda? I think I have soda in there.
No, it's okay, thank you.
You have headache?
Kind of.
Okay, you won't put your head down, it's fine. I'll record it.
No, it's okay. I'll write everything down.
Okay. No, you can put your head down. It's okay. It's up to you. So 4 minus x squared, find a point on the function that is closer to 0, 2. So what's the best way to approach this? What kind of equation I'm thinking about? Well, it's not going to be a midpoint formula because we're not trying to find the middle of something. Right. Do you know what's the distance formula?
It's, I think y2.
Yeah, x2 minus x1 squared. And that's it. Okay, so what happened is we're going to insert those points in here. So this is 0, 2. I'm going to plug into here and here. And that's going to give you d is equal to square root of x minus 0 square plus y. I don't use y2 anymore because I'm just going to plug in the coordinate. So any questions here? Is it going too fast? No? Everything okay? It turns out we already have a constraint. The constraint's right here. Is given to you the equation because that's the. So we are looking for any random point here that is closest to this point, to closest to 0, 2. And then I'm gonna say d equal to square root of x squared plus y. I'm gonna substitute. So I'm gonna substitute as 4. Oops, my bad. It's gonna be 4 minus x squared. Why? Is because the functions and the minus 2 square. So this here get it from, sorry, this here get it from here. Am I going too fast? So d is equal to x squared plus, this is 2 minus x squared square. Whatever you do, don't kill a puppy here. Means you distribute the power inside. You're not allowed to do that. What's the best way to analyze this? Well, the best way is to distribute that. I'm gonna get rid of all those. Okay. So the best way is to distribute properly. So I'll distribute on the side. And always do this even on SAT. Make sure you do it right. So because 2 times 2 is 4. Minus 2x squared minus 2x squared plus 4x squared, x to the 4th, sorry. Am I going too fast here? Let me know if I am. Huh? I expand this. Do not kill puppy by saying 4 minus x to the 4. I'm Chinese, but doesn't mean I will eat dogs. Even though I have no idea why Chinese people eat dogs.
Is that I don't want to sound offensive, but I don't think that's a thing. Is that actually a thing?
That's actually a thing.
Okay. I wasn't sure.
In Beijing Olympic, they actually had to shut down those vendors because they don't want to embarrass them as a nation. But the people eat dog happen to be in Beijing, so and Beijing is the capital where they host the thing. So they had to shut down the vendor that's selling dog meats. So because they don't want to embarrass them as a country, because other people's gonna think they're uncivilized people, which is in many cases they are. I'm not defending Chinese people at all. It's not worth defending. It's pretty sad. Actually, I hate Chinese people. I feel ashamed of my own race. I don't know if I'm allowed to live stream this. Oh well.
Just say it's a joke.
Just kidding.
Just kidding. Just kidding.
As you should.
Oh my
It's
goodness.
easy to say to your students, and like, all your students know this.
You never know.
So let's take a derivative of this. And if I take a derivative of this, so this is a trick. A trick is when you talk about distance, you just want to find out the overall value is. So technically, the radical doesn't have to be there. I mean, you still can take a derivative while it's there, but just a lot more disgustinger. So I'm just going to talk about this part. Why do I only take a derivative of this part? Because I don't really care about whatever final result, I'm still going to square root it anyway. So I'm just finding out what happened inside material is maximized without worry about the radical there. So I can do that only in this situations. So d prime as equal to 4x to the third minus 6x. Do you understand that? Why I dropped the square root?
Can you explain it again?
Yeah. So imagine if I have square root 100 and square root 36. Do I need a square root there to recognize 100 is bigger than 36? Or 10 is greater than 6? It didn't matter, long as the inside number is greater than the other one, so it doesn't matter. So in this case, square root is not relevant. You only care about what inside materials is the maximized. But whatever maximized, you're gonna square root regardless small number or big number. It didn't matter. Does that make sense? They are related. It's gonna square root as a result anyway. So it doesn't matter. As long as you find out what is the biggest value in here. To square root or not square root, if you square root, you're gonna square root on both number anyway. So you compare with that. So 0 equal to 4x cubed minus 6x. And that's equal to 2x times x squared minus 3. And the x equal to 0. And here's 2x squared, so x squared equal to 3 over 2. X equal to plus minus 3 over 2. So you got three different values here. It could be the short distance or longer distance. We don't know which one's which though. So how do I know which one's which? Well, we talked about it before. We can do a double derivative. If I do double derivative, the double derivative here in this case, it's going to be 12x squared minus 6. And if I do double derivative with 0, I plug in. Obviously, it's going to be 12 times 0 squared minus 6. That's equal to negative 6. Is that maximum or minimum? No. Is that a Karate Kid situation? Right? Is concave down? It's concave down because the second derivative at this critical value. Critical value happen at 0, square root 3 over 2 positive, square root 3 over 2 negative. If it's concave down in that situation, then it's automatically maximum. So this is actually the maximized distance. This is not what we want. We're going to cross this one out. Boom, boom. Don't care. We have to pay attention to d double prime of square root 3 over 2. And that's equal to 12 square root 3 over 2 square minus 6. That's 12 times 3 over 2 minus 6. That's equal to 18 minus 6 is 12. 12 is concave up or down? Concave up, right? Is concave up, what happened? It's a minimum. And we want to minimize the distance, not maximum the distance. So this is minimize. So at square root 3 over 2 is a solution. So you're going to say square root 3 over 2 is about 1.2-ish. So at this part, it's going to have the shortest distance here. Can I figure out a coordinate? Of course. We're going to take the square root 3 over 2, plug into the original function, which is 4 minus x squared. Y equal to 4 minus square root 3 over 2 square. That's 4 minus 3 over 2. equal to 5/2. So basically, you have a smallest distance at square root 3/2 positive, and then 5/2, and negative square root 3/2 to the 5/2. Why? They are symmetrical, they are parabola. Those two sides equal to the shortest distance. Yep.
Can you explain the concave and stuff? Like, is it because it's negative? It's
Yeah. If it's negative, it's concave down, right? And it's concave down at that critical value is a relative max. When we did the Karate Kid, do you remember that?
yeah.
So it's a relative max. But that's a maximize the distance, not minimize the distance. So ideally, I don't want this. I don't want a -6. I want it to be positive 12. Why? 12 is concave up. Then you have this, then is a minimum. So that means that's a minimized distance as opposed to maximized distance. So this exact same question or different number is going to be on the test. I'm just going to tell you straight like this. You're going to get a couple practice today. You're going to have answers. You can look it up, see if they have the shortest distance on decimals, and you can find out what is right or wrong. So if you want to practice what's on the test, today's homework, there are 2 questions out of 6 is on today's homework. It's 30%. That means you still will fail, but you have 33% higher than before.
So, what is on the test? 'Cause
This is the 2 question will be on the test. And one test question is going to be with 2 numbers. 2 number is sum of something. Those are easy, I think. Like one number. One number of first number, like remember that first 2 questions that we deal with, you had to write out what's constraint and what's primary.
Oh, yeah.
So product of 2 number equal to 192. Yeah, you're gonna have one of those questions, and you're gonna have 2. This is the first one here we covered today. That's on the test. And there's a practice question. So we're gonna talk about this question also. We're gonna give you a practice question before you go. So we're gonna do these questions here. So sorry, let me erase this, and we're gonna go over the second one. So this is the second question that it's on the test. You might not get y equal to square root of 25 minus x squared. I'm gonna give you couple different look of this question. Basically, we want to find out what's the biggest rectangle you can fit into the situations. So first of all, do you guys know what's y equal to 25? Square root of 25 minus x squared graph look like?
Say that again?
Do you know what's y equal to 25 minus x squared graph look like?
Would it be like this?
Huh?
Would it be like this?
No.
Isn't it just like a parabola?
It's almost like a parabola, but it's not. Because 25 minus x squared is a parabola. But square root of 25 minus x squared is not a parabola.
Right, it's
Oh,
just
wait, is
one
it?
side of it?
Isn't it like this? Like that?
That's the square root of an x graph, not square root of x squared graph, especially not square root of 25 minus x squared graph.
It's like one of those graphs that's like the parabola and then those 2 sides.
Oh, you were thinking about like a W shapes?
Yeah, there's W, because like if it's an even number, then it's like.
No. So this is the graph I told people that you have to know. It turns out you know this graph. Okay, let's look at this, how to draw this first. Let's say y equal to 25 minus x squared. Now I'm going to guarantee you know what this graph look like if you square both sides.
Way square both sides.
Yeah, if I square both sides, what would the graph look like? Does that remind you anything?
Oh, it's a circle.
It's a circle, yeah. So y squared equal to 25 minus x squared. If you move the x squared to the other side, guess what? It's a circle with a radius of 5. So that means, what is this? y equal to square root 25 minus x squared.
Half a circle?
Exactly. So, good job. Is a plus minus is a full circle, but is a plus is the top part of the circle. So, and so we had two things in one stone, which is we talk about equation of a semicircle, which is we're gonna do later when we deal with something that's harder. So, now this is a boundary. The boundary is gonna be on the bottom. So boundary is x bound, so x bound, the x is going to be a little bit bigger. And we got a -5, we got a 5, we got a -5. So it's going to have some type of circle like this. Now remember, this is positive, so therefore it's a positive part of the circle. And your test question is not going to be as hard. It's not going to give you a semicircle. But it can, if you want to. And maybe I'll give you, you should end up to feel like it's easier because something you've seen before. Now, I'm going to do is, they say a rectangle is bounded by x-axis. So some type of rectangle, well, of course you're not going to fit a rectangle like this. That's not going to be a biggest rectangle, right? So you want to stretch out as much as you can. So technically you can have something like this, or you can have something like this, right? Or something like this. Really, really depend. We have to find out how big that rectangle is. So then let's just say, well, we don't know how big that rectangle is, but I'm just gonna draw something arbitrary to help you analyze. So we're gonna see here is gonna give you some type of rectangles like this. So what we're trying to maximize, we're trying to maximize area of this rectangle. So let's just say area. What will be area in this case? Well, remember, we haven't assigned some variables yet. So I'm going to assign this as x. That makes it a lot easier. What about the height of rectangle? It's y. But y is also equal to another function. What would be that function? Yep, that's it. So what would be the area in terms of this, the primary here?
Wait, can you have that where one variable is the function and a variable?
Yeah, because x is how far I can span. So whatever input there, I just plug in the input to get an output to find out the height. So let's just say if it's a 1, right? If it's a 1, then you're going to have a rectangle like this. But based on what? The 1, you have to plug in the original function to get the y value, which is the height. Does that make sense? If it's 2, then it's going to look like this. Right? So what will be area here?
X, Y. X times Y.
You sure? We're talking about rectangle, not the semicircle.
Oh, I was gonna do minus the, okay. I was gonna minus the.
I see what you're saying. Then it's gonna minus that weird leftover shape. You don't want to do that. That's kind of messy. It's not xy though, but it's pretty close to xy.
Oh, x squared.
Why do you say 2xy?
Because
There's two.
Yep, there is 2.
Jeez.
So guess what? We can, this one I was trying to optimize, and we do have a constraint. The constraint is bounded by the functions. It's bounded by the functions. And you're like, yeah, I got an area equation. What do I do after that? Yep. And you have to keep the square root this time. The reason why this time we're not talking about distance, we're talking about area. So I'm going to do product and chain. 2 times 25 minus x squared to the half plus 2x times 1/2 times 25 minus x squared to the negative half times negative 2x. Now what happened is those two usually simplify, make your life easier. I'm gonna factor out a 2 as well as 25 minus x squared to the negative half. Once I factor out, I'm gonna use a different color. So that 25 minus x squared is gonna turn into the first power because 1/2 minus negative 1/2. So it'll be 25 minus x squared. And then what do you have left? Well, the 2 is gonna be out, x and x, which is minus x squared. So therefore it's equal to 2 times square root of 25 minus x squared. And this one is 25 minus 2x squared. I just set the top equal to 0. So it'd be negative 2x squared equal to negative 25. X squared equal to 25 over 2. X equal to plus minus 5 over square root 2. Alright, square root of 25 is 5, square root 2 is square root 2. So this is plus minus square root 2. So we see this x equal to 5 over square root 2. And the x equal to 5 over square root 2. So therefore the width of this rectangle is going to be what? 2 times that will be 10 square root 2 is the width of rectangle. Because 2 times that.
Hold on, let's show you.
When you set the top equal to 0, why did? Oh, wait, no.
Why didn't I set bottom equal to 0?
Oh, no, I see what you do. You just divided 0 by 2.
I move the 25 over and divide by negative 2.
So wait, why are you not setting the denominator equal to 0?
Denominator equal to 0 is going to be 5. 5, you cannot form a rectangle. That's how big the semicircle is. So that kind of like that's a physical restriction there. Because of the 5, there's no rectangle existed. Because there's no height. Does that make sense?
Does that work for all? I mean, like,
No, I mean just in this case that you have to think about physical restriction. The biggest thing that you can have a rectangle is 5, but if it's 5, there is no rectangle. You're gonna form a 5 from here to here. There's no rectangle at all. You can form. So what would be the height though? The height is gonna be what? Well, the height is gonna be plug in. So plug in 5 square root 2, so it'll be y equal to 25 minus square root 25 over 2 squared. So that's equal to 25 minus 25 over 2, which is square root of 25 over 2, which is same thing. So it would be square root 5 over 2. No, sorry, 5 over square root 2. And if you want to know the area, well, area is going to be 50 over 2, so it's 25. So this is 25. I just multiply those two, width and height here, which is length and width in this case. I got this.
Wait, how'd you get height equals 5 over 2? Isn't
I plug it into the original equation. I plug in the 25 minus x squared.
wait, 5 over square root of 2, isn't that the width?
It's also x. No,
Oh wait, no, never mind.
Yeah, 5 over square
No,
root of
that's
2
not
is
x.
x.
It's 2 times that.
Wait. Why is it 25?
If I plug in, because it's 50 over 2, right? 25 is 50 over 2. So 50 over 2 minus 25 over 2 is 25 over 2. So same length. Kind of makes sense. You're going to have the same exact rectangle inside. The height is going to be equal to half the width in order to form that rectangle. Kind of logistically that makes sense. The ratio always going to be true. Now here's a practice question I'm going to let you have. This is the first one. I want to find the shortest distance And you're gonna get a fraction here. Numerator plus denominator is 9. If you did it right, numerator plus denominator is equal to 9. Okay, so you got one question. You want to find the shortest distance. Find the shortest distance from 4, 0 to square root of x. Find out the coordinate of that. The x value is going to be square numerator plus denominator is going to be 9. Now the second practice I want you to give you is y equal to, I would say 4 minus x squared, and I want to find the area of a rectangle. Find the area of rectangle that is bounded by x-axis as well as the functions. And why don't you find out what's the biggest rectangle that is. Find the area of the rectangle that is bounded by x-axis as well as y equal to 4 minus x squared. And I need you to maximize the area. Maximize the area of rectangle. Okay. You guys gonna practice on this 2 questions, and this might be just this is the first 2 homework questions. I'm gonna post other one.
Also, I won't be here on Thursday and Friday because I'm going to lesbians.
What time will you
So-
be back?
Like 9.
Oh, it's gonna be very late.
So
Okay.
yeah, I can't take on Thursday and Friday, so I have to take it tomorrow after school. Are you free tomorrow?
Yeah, I'm free.
Okay.
So just this 2 question plus all the question before. So this is the last 2 questions we're gonna go over. So just practice on those 2 questions and make sure you understand all the question before.
Yesterday and the day before this.
Yeah. So I'm not gonna put in the linearization for you because that won't be fair because you are not here for Thursday or Wednesday. So but other people they will have a linearization that I have to deal with, and you just take it when you come back once you watch the video.
Okay.
So if you just find 1x, do you need to do the second derivative?
You can test it, just make sure. You should get numerator plus denominator is equal to 9. If you did that right, then